Good evening. I'm Karen Taylor, Program Director of the General Society of Mechanics and Tradesmen of the City of New York. And I'm delighted to welcome you to tonight's talk, which is part of the Labour, Literature and Landmark lecture series, and is our final lecture for this series. We will start with a new season in the fall. We have had 24 online lectures over the past 10 months, and I want to express our huge appreciation to the 24 plus lecturers who have shared their expertise so generously during the series. We'd also like to take this opportunity to thank the New York Landmarks Conservancy for their partnership of all the landmark lectures, including, of course, tonight's talk. For every single one of these 24 talks, we have had the behind-the-scenes assistance of the General Society archivist, Angelo Vigorito. So thank you, Angelo. I also want to thank Connie Munya for her help with tonight's program. Finally, you'd be glad to know this is the end of the thank yous, but we want to thank you, our audience, for your support of this lecture series. Many of you have attended multiple lectures throughout the year, and we're very grateful and delighted that you can be here again this evening. For those of you who might be less familiar with the General Society, a brief introduction. The General Society of Mechanics and Tradesmen of the City of New York was founded in 1785, 236 years ago. Today, our organization continues to serve and improve the quality of life of the people of the City of New York through our educational and cultural programs. These include our John M. Mossman Lock Museum, our tuition-free Mechanics Institute, our General Society Library, and of course, this lecture series, which was getting closer to being nearly 200 years old. At the conclusion of tonight's talk, there will be a short 10 to 15 minute Q&A. Please feel free throughout the talk to submit your questions through the Q&A section, and of course, at the conclusion of the talk. And we do ask that you would use the Q&A section rather than raise your hand. Tonight, I'm very pleased to introduce Mary Jablonski to talk about Coignet Building in Gowanus, Brooklyn. Mary is the president and founder of Jablonski Building Conservation, Inc., and has over 26 years experience in historic conservation. She oversees the firm's projects to ensure a consistent methodology is applied across projects and to maintain quality control. She has special interests in decorative finishes, early 1800 frame buildings, and modern materials, including plastics. She is a fellow of the American Institute for Conservation and the Association for Preservation Technology, and is also an adjunct associate professor in the Historic Preservation Program at Columbia University. Mary, a very warm welcome.
Thank you. Sorry, I had to unmute myself there. Usually helps. So good evening, and thank you very much for having me. I'm going to apologize for a couple of images that look to be a little fuzzy tonight. I tried to reduce the size of this, and I think I reduced image quality a little too much. But anyway, we're going to start off with this incredible building, the Coignet Building, which is a building of many stories. And one of the stories is the early development of concrete. It's also a story of a neighborhood preservation group that was really good about making locals understand the importance of their neighborhood. It's also been a story of development, politics, and misunderstandings, a little bit that I'll touch on there. But it's also an incredible lesson about how we need to reach out much more to the public with information on the importance of the history of concrete. I'm probably preaching to the choir here. After all, none of you would be here if you didn't think this was interesting. And some of the early mistakes with this building were really about the lack of information easily accessible to the public and the building trades. In the early 2000s, there was this really forlorn, decrepit building that stood alone on a corner of industrial Brooklyn. Most people probably passed it by without a thought, while others wondered when it was going to be torn down. A few preservationists and local residents interested in history knew its importance. This lonely Coignet building was once the pride of the New York and Long Island Stone Company. And when the New York City Landmarks Commission designated it a landmark, they called it a pioneering example of concrete construction in the United States. Now, the story of the Coignet Building is also the story of an early industrialization of New York and Brooklyn. It was the beginning of the great romance between concrete, cement, and the building industry. The building was the headquarters of one of the first firms in the nation to industrialize the production of concrete. And although this building and its history are tied to developments after the Civil War, it was inventions in Europe before the war that led the way to the development of the New York and Long Island Coignet Stone Company. It was a Frenchman, François Coignet, who invented a concrete process known as Coignet béton, also called béton agglomère. Now, in this period, exhibitions were where new inventions and new technologies were showcased. François Coignet exhibited at the 1855 Paris Exposition, where he brought his many processes to the attention of those interested in new building techniques. And it was after the Civil War that two Brooklyn businessmen traveled to France to meet with Coignet. One was Quincy Adams Gilmore, a West Point educated structural engineer who had risen to the rank of general during the Civil War. Through his military studies, he became quite fascinated by fortifications and building materials, and he had actually researched Coignet's processes and even written a paper on them. The second man was a doctor named John C. Goodrich Jr., also interested in this new concrete construction. He wrote most of the publications for the new company, and he secured a lot of the patents for concrete manufacturing. Goodrich became president of the new company, and him, together with Gilmore and two other men, they would make up the officers of the new Coignet Agglomère Company of the United States, formed in 1869, Brooklyn's first concrete company. It was one of the first firms in the nation to industrialize the production of concrete. For this, Coignet sent over trained staff from France to teach the Brooklyn management and workers the Coignet patented techniques for manufacturing. And the first factory was what is now known as Carroll Gardens. And here they used molds instead of chisels and cutting tools to fabricate building elements at a cost far lower than using natural stone. There were claims made that their artificial stone was indistinguishable from natural stone. Probably not quite, but close. And the factory made all kinds of concrete building elements, but specialized in stone blocks, both large and small. This is actually an image of a little bit later when the company became the New York and Long Island Stone Coignet Company, but you can see all the bits and pieces that they were fabricating, including window tracery and urns. They even manufactured a Coignet brownstone, which was said to be superior in all ways to natural brownstone. And you know what? It probably was to most. By 1871, the company could boast that they could manufacture the front of an ordinary house in one day. And 4 buildings of Coignet béton were built by A.S. Barnes on Clinton Avenue, Brooklyn in 1872. This is a relatively recent photograph of these buildings at 536, 540 Clinton Avenue. And you can see they're still existing. They're in reasonably good condition, although the center building seems to have undergone some major alterations and renovations quite recently. And if you notice, this stone actually, cast stone looks much more like limestone, not brownstone. But the Coignet béton was not merely limited to buildings. This cliff ridge span in Prospect Park was designed to be formed of concrete and brick, but the New York and Long Island Quante Stone Company offered to make the whole span with their patented stone. And the architect, Calvert Vaux, agreed to this, and the experiment proved actually quite satisfactory to all parties. And of course, the principal advantage for this was they could easily produce a lot of the decorative elements quite quickly. And it was much faster and less expensive than carving these units. And here again is a relatively recent picture of this bridge. And you notice that it seems to be in quite decent condition. Now, as Brooklyn was developing industrially, the Gowanus area became central to the development of Brooklyn. In the 1840s, the Gowanus Creek was a tidal estuary flowing into the Gowanus Bay in New York Harbor. The construction of the canal began in 1849 and was accomplished by deepening and widening the Gowanus Creek and creating bulkheads, or putting in bulkheads rather, along the waterfront. The canal was fully built out by 1869. It became the center of the industrial growth in Brooklyn, and by 1880, actually, there were 31 firms operating in different industries, such as lumber, coal, hay, grain, and of course, building materials. A decade later, these industries expanded to also include the utilities such as gas and electric. But the industrial development spurred also residential housing surrounding the canal basin for canal workers. And the Coignet Building Company became part of this growth. As its materials became more popular, there was a need to expand their factory beyond the Carroll Gardens site. They decided to move to the new Gowanus Canal to the large manufacturing space on 3rd Avenue. It would allow them to easily bring their cast stone into the heart of developing Brooklyn. And here you can see where their factory site was. And the red circle is actually the Coignet Building. So the factory on the Gowanus Canal was accessed by the new 4th Street branch of the canal, and fabrication materials could be received at the factory, and artificial stone just shipped right out the door. As the new factory went up in Gowanus in 1872, the company changed its name actually to the New York and Long Island Stone Company. By this time, it was reputed to be able to manufacture the fronts of 10 houses a day, in addition to all the other decorative elements they made. And their stock list included columns, blocks, keystones, window tracery, and of course, urns. In addition to their factory, they required a building for offices and showroom. Built in approximately 1872, although there's some sort of the date might be 1874. This building was reputedly designed by William Feld and Sons, and the building became part of the 5-acre factory complex that ran along the Gowanus Canal. Of course, the company constructed their offices with the Beton Coignet cast stone. After all, it was serving as a model of the work that could be done by the company. Customers could see the possibilities of this cast stone actually used. The blocks that made up this building were tinted and treated to resemble stone. Now they could resemble either the grayish-white granite, brownstone, but here they actually used it as looking like limestone. The foundation, original floors, and spandrels between the windows of this building were made of poured reinforced concrete with a brick backup wall. The exterior walls and all of the ornamental features of the building, the columns, porticos, windows, and doorways, were all cast stone elements, cast in molds that could be customized as per the client's needs. In 1874, the Scientific American noted, quote, "The process of manufacturing consists in first grinding down the constituent elements of the stone to be imitated, and then mixing them by machinery until they reach a plastic state. The molds are then filled by a peculiar process which entirely excludes the air and are immediately removed. The stone within a few days is ready for transportation and continues to increase in density," end quote. The article went on to report, quote, "The beton is impervious to water and withstands the effect of frost and will withstand a crushing pressure of about 4 tons per square inch," end quote. Unfortunately, the company did not last long. The company filed for bankruptcy in 1875 and auctioned off its patents in 1876. John C. Goodrich never gave up on concrete or his methods. He tried to reorganize the company in 1877 as the New York Stone Contracting Company and sent out press releases announcing that he improved on the original Quante methods. But the demand for the béton aggloméré product had declined. The company began making reinforced concrete forms for non-residential purposes, such as the lining of tunnels and the repairs of piers and abutments. The company building passed through several hands until the 1960s. Much of the building's visible facade was modernized and faced in red brick veneer, possibly to hide deteriorating cast stone. The original blocks were mostly obscured, as was the history of the building and the concrete industry in Brooklyn. The rise of the Gowanus area in Brooklyn in the early 21st century brought a new focus to the Gowanus area, and it also brought Whole Foods Company into the area. In a deal with the owner of the Coignet property, Whole Foods would restore the building's exterior as part of the deal to purchase the land surrounding it. The building was in poor condition and stripped of much of its interior finishes. The architect who had designed the Whole Foods store, which I have to say is a really quite beautifully designed store, had never worked on a historic building. The same held true for the construction manager. And another sort of bit of unfortunateness, the New York Landmarks Commission permit allowed for extensive replacement of cast stone. Now, mistakes do happen, and the masonry contractor bit off more than he could handle, and he had no idea that this was not a modern type of cast stone. After construction started to repair the Coignet Building in 2013, my firm, Jablonski Building Conservation, was asked to join the restoration team. There'd been a little bit of a misunderstanding on the part of the mason contractor about how to perform the work. Well, this was not what we got to survey when we got to the site. This was what we got for the survey. A partially scaffolded building with limited access to many parts of the building. And also you can note at this point, the Whole Foods building is built there and it almost abuts the building, giving very little space for two elevations to be surveyed. It was difficult to gain any kind of vantage point in those areas and challenges abounded. Now, when preserving or restoring a historic concrete structure, it's absolutely vital to understand what you have. And this requires time and planning. You need to analyze the concrete, you need to develop mixes, you need to provide time for adequate aging of mock-ups for matching to the original concrete. You need to understand how the cast stone was made, and you need to know how the building was constructed. Our conditions assessment started as demolition was going on around us. The displacement of some of these extremely large cast stone units, and hopefully you can see here some of these units are really quite displaced, was very disconcerting. The blocks were large and there was nowhere to run if anything went wrong. The realization of the amount of work required was a bit overwhelming, as this displacement was fairly typical for conditions on the building. It was soon apparent that the cast stone was a veneer, but we didn't know how it was attached to the backup wall. And the demolition occurring at the top of the building as we were surveying didn't add to our comfort. We found a few masonry anchors, but most of them were rusted or in poor condition. We found significant cracks, including hairline cracks everywhere. There was a lot of weathering due to wind, rain, snow, pollution, acid rain, and even salt water. Don't forget, New York City's not far from the ocean. There was erosion of cement paste, exposure of aggregate particles, and a loss of crisp edges. There was still brick face on two facades. You can see some of it from the older one. And actually there was this interesting phenomenon that we also found here, and that was almost all the projecting, in fact, all the projecting corners were broken or patched. And possibly this was because they were exposed on four sides, but it appears to have actually been a weakness in the casting of these units. There was also a lot of cementitious white paint on any of the cast stone units that had been left exposed. And just to top it off, there was bituminous coating on the back of the building. Most of the window openings were collapsing. The keystone had actually fallen out of one of the openings, which was being shored up. Just to make it even more exciting, the backup wall was collapsing in two locations. Another important piece of information that we needed for this project was what was the Coignet beton made from? Several people had informed the Landmarks Preservation Commission that the cast stone was natural cement. And that was a reasonable assumption. David Oser, who was the first to make Portland cement in this country, or at least make a usable one, made his Portland cement started fabricating his Portland cement in 1875. And the Coignet Building is 1874. And in the US, the first large scale of cement was Rosendale cement, a natural cement, which was discovered in the 19th century near Rosendale, New York. Now, Rosendale was extremely popular at this period. It was used in the Statue of Liberty, the Capitol building, the Brooklyn Bridge, the Erie Canal, and also lined a lot of water pipes. But while the United States was not producing Portland cement until 1875, it was importing it. The first recorded shipment of Portland cement in the United States was in 1868. And now, there was a bit of research that John Walsh from Highbridge Materials Consulting turned up on Gilmore's writing on the topic. And it was in 1871, Gilmore had published a practical treatise on Coignet, beton, and other artificial stones. And a couple of his comments are quite interesting. For beton glomère, he says, this name is given to a beton of very superior quality, or more properly speaking, an artificial stone of great strength and hardness, which has resulted from the experiments and researches extending through many years of Monsieur François Coignet of Paris. And he notes, first, only materials of the first excellence of their kind, whether common or hydraulic lime or hydraulic cement, can be used for the matrix, but Portland cement was the best. He also felt that the quantity of water must not exceed what was barely sufficient to convert the matrix to a stiff, viscous paste. Then he noted that the matrix must be incorporated with the solid ingredients by a thorough and prolonged mixing, producing an artificial stone paste, decidedly incoherent in character until compacted by pressure, in which every grain of sand and gravel is completely coated with a thin film of paste. There must be no excess paste when the matrix is common lime alone, or with hydraulic lime. This precaution is less important, and with good cement unnecessary. He also noted the beton, or artificial stone, is formed through thoroughly ramming the stone paste in thin successive layers with iron shod rammers. And finally, he noted that the heavy, slow-setting Portland cements, natural or artificial, are the only ones suitable for beton glomère. He also noted that none of the cements made in the United States were capable of producing a matrix suitable for the beton glomère of good quality. So we needed to take samples that we could analyze, and we were told that we were to take an absolute minimal amount of samples that we had to. So we were limited. We selected locations. We took samples, as you can see on the right. The petrographic and chemical analysis of the cast stone was performed by Highbridge Materials Consulting. John Walsh was ecstatic to be actually looking at this stone. And I can't emphasize enough the importance of using petrographic analysis as part of any thorough investigation to an on-site condition survey of deteriorated concrete structures. Too often, conclusions concerning the nature or cause of deteriorated concrete, as well as the repair of the same, are based on visual observations only. But petrographic analysis can be used to identify chemical and physical elements of the concrete, including the nature of deterioration, the identification of aggregate strength, mixture proportion estimates such as water and cement ratio, aggregate size and distribution. And we actually found some really fascinating findings from this. This was the aggregate. Now, a number of you probably are quite conversant with aggregate in Portland cement or in cast stone. This is extremely fine aggregate, not what you would ever think would be found with concrete. Another incredible finding was that this was pre-rotary kiln Portland cement. It was European, probably French or German, not natural cement. And in the early days of Portland cement production, kilns were vertical and stationary, as you can see on the left. It was only in 1885 that an English engineer developed a more efficient kiln that was horizontal, slightly tilted, and could rotate, which you see on the right. The rotary kiln provided better temperature control and did a better job at mixing materials. By 1890, rotary kilns dominated the market. And just as an aside, in 1909, Thomas Edison received a patent for the first long kiln, which he installed at the Edison Portland Cement Works in New Village, New Jersey. And it was 150 feet long, which is about 70 feet longer than any of the other kilns used in the period. But back to my Quante Beton. The other findings were that it was dry tamp, or a very dry cement that was rammed. The beton was actually itself in excellent condition. There were no major durability issues. The problems that we had seen with the cracks were consistent basically with structural rather than material issues. And there was only minor evidence of internal cracking found in the samples that we had examined, and some of this cracking was also due to some freeze-thaw cycling. There was no natural cement in this in this cast stone. However, there was natural cement in the mortar used between the cast stone units. So as we were conducting our conditions assessment and Highbridge was undertaking the petrographic analysis, work was continuing on the Coignet Building. It became very clear from our report that the current scope of work for the contractor had to change, and the new scope was really outside their skill set. Luckily, the contractor did not wish to continue with the project. A new contractor had to be found. And Stone and Lime, a Massachusetts firm and a masonry contracting firm, was brought onto the project, and there was very little time to complete it, so a very quick reset had to be done. A repair strategy had to be designed, and there were some really major constraints. Time was a major one. The previous contractor had cost the client almost a year. Portions of the building were rapidly failing. And the landmarks permit allowed for extensive replacement of the cast stone unit, which had led to a number of units actually being lost. A great deal of the material was missing from the top of the building. And the question was, what should one put back, or should one leave the building to show its age and scars? The problem was we had very little documentation about what had really been built. And this is just an example here of showing a fairly early photograph with the graphic of the building, and you can see that there are differences between the two. So the graphic is actually fairly misleading as to what the actual building was. And also, all of the corners on this building were damaged and were patches. There were no original corners left. So the most important decision was how much of the cast stone were we willing to replace? Replacement of original materials should be the last resort. But who defines last resort? What defines a piece of cast iron as beyond repair? Traditionally, many of us have replaced concrete and cast stone wherever it's deteriorated. This building, with its very early cast stone and a technology long lost, made me seriously think about what this means for authenticity and even losing the historic record. One of the most significant historic and technical aspects of this building is that it was built to showcase a specific material, Coignet Beton. The entire building was covered in it. There were flat pieces and ornamental pieces and large pieces and small pieces. We decided that it was really important to save as much of the cast stone as possible. The actual units were too important to lose. And once we made that decision, we were able to determine how we wanted to move forward. I should note at this time that we were having a discussion about casting the units at the top of the building and what to do in the parking lot of the Whole Foods with the Whole Foods executive and the contractor. And one of the employees of the store who lived in the area came up to us and spoke to the executive at Whole Foods to say to him how important this building was to the history of the neighborhood. It kind of took the guy back, but it made him actually really think about the building, and it was very helpful. So very much thank you to that employee. Oops. So there were some easy decisions to make about this. One, the brick face had to go. It was taken off and the facades had to be resurveyed. There was a lot of work to do, as you can sort of see here from this drawing. The paint and cementitious surface repairs all had to be taken off, and it was very labor intensive. Removing the brick face was extremely difficult, to put it kindly. And it was the difficulty that the previous contractor had trying to remove it that was the initial reason we got called in the first place. And this was sort of kind of what happened, and we had to even out the surface on this. Now, the vast majority of concrete preservation projects are triggered by visible damage, and therefore patch repair of concrete is really an integral part of any repair. Despite this being a common repair, the techniques for doing this is a lot of widespread disagreement over what should be done and what the parameters are. And with this level of sort of disagreement and a lot of lack of knowledge about durability of types of repairs, it really makes for a difficult conversation. And there's various materials you can use. We decided, because this was a Portland cement, that we were actually going to make repairs with Portland cement, which is what we did. We also had this incredible problem of the size of the units. These units were huge and weighed a lot. And you can see the size of these units next to these two workers. And again, here you can see the guy palletizing and just how big these units were. There was no place to work on these units at the site. They all had to be trucked off the site to be worked on in a factory shop. Now, the first contractor had thought they were going to remove the displaced units at the top of the building, fix the brick backup wall, and then install new cast stone units. These incredibly large units were difficult to remove, particularly as most of the building was boxed in by Whole Foods by the time anybody started doing the restoration work. There was really little room to maneuver the blocks down from the building. It also appears the first contractor had no idea the weight of the units. The scaffold was not really strong enough for the job. In fact, I was on the scaffold with the second contractor looking at the building when the scaffold was hit by a truck. It luckily didn't collapse, but it got replaced very shortly with a much more robust one that could allow for the weight of the Coignet Building units. Now, another unfortunate occurrence with the first contractor was that in order to get the units down, the workers jackhammered the large units into smaller pieces. So our job was then to try to piece together as many of these pieces as we possibly could. And here you can see one of the pieces being put back together and being patched. And tension rods were sometimes used to get these pieces to hold together. Working on the surface repairs was very labor intensive, and the patches not only had to match color, but they had to match the weathered surface. We actually made the decision to lime wash the building, and it wasn't made lightly. There were two issues. One, the cracks on the building could be bridged with a lime wash, but it would also offer a lot of protection to the cast stone units. It wasn't a permanent coating, but it would increase the lifespan of the building and serve as a protective coating. And we felt this was particularly true for a lot of the very weathered decorative elements. The third reason, actually, we decided to go with a lime wash was to provide a more uniform surface appearance, which was the intention of the original design. We had no time to age our patching and the mix used to create new units. We expected the repairs that we did would not always match the color of the original units. Now, concrete patches can be made that match the original material for a short period of time. However, as the concrete cures and ages, the colors of the repair mixes start to diverge from the original color. And this is often apparent 6 months to a year later. This is why it's necessary to have time to design repairs in concrete mixes when restoring concrete buildings. Ideally, patching mixes and any mixes for new concrete material would require a year or two to get right. For a building of this importance, it really needed to have been done long before. Unfortunately, there is little written literature with this recommendation. The International Masonry Institute and Amy Lamb Woods certainly have been working to rectify this. And there are some other publications that are useful resources that have come out. One of the most recent ones actually is this Getty publication on concrete case studies, which I highly recommend for anyone interested. The repairs did make a significant difference to the building, as some of the before and after images here show. Just to give you a couple of examples. So in the end, the isolated Coignet building was restored. The building was no longer forlorn. It served as a reminder of what once was an innovative company, but it does not any longer show the context of industrial Brooklyn or its relationship to the canal, which is hidden by the Whole Foods story. The canal is actually behind the store. So how has the building weathered since its restoration? Moderately well. The lime wash is actually weathering off the building. We had warned the owner, which was not Whole Foods, that the building would require recoating. It no longer looks pristine, which is beginning to show, I guess, a patina of age that does help with the building's interpretation. The building does continue, of course, to weather. You can see here an image of the limestone washing away, the lime wash rather, washing away. And it appears that there's a little bit of settlement in this building due to actually some groundwater issues adjacent to the building. And no, the restoration was not perfect. The lime wash issue certainly, the lime wash was an issue on several fronts, and there were some people who thought it was a permanent coating. One of the issues I find major is the different rates of absorption, particularly visible during rain, of the original and the new stone units. Treatments were undertaken with a lack of long-term and evidence-based information on the efficacy of the treatment methods. And this is particularly true for the patching of béton aggloméré. There's also an absence of agreement within the field on basic procedures and methodologies for concrete conservation and repairs. Effective repairs alter the appearance. We chose to keep the patched rounded corners instead of recreating corners that we did not have examples of. We think the original were pointed, but we didn't know. We hope the repairs to this building will assist in the information about the efficacy and the use of concrete repair techniques. For a building that was about so many firsts, it deserves to continue to serve as a resource about concrete technology. I wish to thank John Walsh, who did so much of the research on the material of the Coignet béton, and Heather Hartshorn, who assisted him in this endeavor. Also, Stone and Lime, who cared deeply and argued long and hard for repairing so many damaged blocks and recreating new blocks in as similar a process as possible. Also, the late Trix Rosen for the photographs of this restored building. They were, like all of her work, spectacular. And a special thank you to our former employee, Kayla Loveman, who worked with me on this building. Thank you.
Mary.
Yes.
Thank you so very much. That was such a fascinating presentation, and also how you took, things that were quite technical for those of us who are perhaps less familiar with concrete and the other things you referred to, and you presented it in such an informative and clear way. So thank you very much for that.
Thank you.
Yeah, no, it was absolutely terrific. And before we take any questions, Victoria, would you like to say anything?
Mary, you are fabulous.
Well, thank you.
I was completely captivated, and your passion for your work and the way you made me feel like it was a true rescue of that building, that you performed that wonderful forlorn building, as you called it, that you gave life to. And thank you for, again, I can't say enough. You know, as someone who works for an organization that's 236 years old, I am forever mindful of collective contributions over time, of generation after generation. As you talked about concrete, I just say thank you to everyone who ever had these, who developed all of these materials, who built these buildings. I homage to all that came before. And thank you, Mary, for what you do to preserve these wonderful buildings, these treasures, really.
It's a team effort.
I know, but thank you. And I could tell you're a wonderful leader, so thank you.
We will now take some questions. This is from Robert Streeter, and he wonders, what's the story behind the truncated elevated stairway on the 3rd Street side?
Because it encroaches on the sidewalk. It's actually going to be put back. The DOT, it's been years. The DOT just gave permission, and that should be happening hopefully before winter time this year.
Okay, that's good to know. Rachel Frankel, she comments, she also makes the point how fascinating and clear the presentation was, and she wonders, what use does the building serve now, I guess?
It is empty. The owner wants a lot of money for the building.
One of those New York stories, right?
Mm.
Yeah, okay. Well, if anyone wants, you know, easy access to Whole Foods, it would be an ideal place, wouldn't it? So
there are people that go and sit on the steps. I don't recommend sitting on the steps. They were lime washed and it'll come off on your clothes.
Okay, well, thank you, Mary, for that very handy tip. Okay, this is from Paul Naprostek. Could you elaborate on the difference between natural cement and Portland cement?
Natural cement is fired in a different way and less accurately, I think, than Portland cement. Portland cement is a very sort of scientific mix, I would say, versus natural cement. But natural cement also is a type of cement that's really great for use in foundations. It's got clay in it, and it's not as rigid as Portland cement. And I can tell you, you never want to put Portland cement over a natural cement, particularly mortar, because it will fail. The natural cement mortar is more durable, I think, in a harsh environment. It was used on lighthouses frequently, and we unfortunately find a lot of Portland cement put over natural cement on lighthouses, which has failed. But it's a more scientific way of making a cement. And there are reasons that the Portland cement is far more durable, and you could never have done a natural cement at the Coignet Building, but you could with a Portland cement. So it's not to say Portland cement is bad. They both have different uses. And there's not much natural cement being made. There's 2 companies in the United States, but for historic buildings, they're both doing a booming business. And we're actually working on the Brooklyn Bridge at the moment, where we're going to be using a lot of the natural cement that's being fabricated.
Oh, that's how interesting. Anyway, thank you for that very comprehensive explanation on the distinction between the two. This is from Gregory Dietrich. He also comments, a fascinating presentation, what a conservation journey. Now he wonders, do the Park Bridge and the Clinton Avenue houses also incorporate brick backup infrastructure?
I don't know.
Okay, well, that
unfortunately.
Would be, right, okay.
I just don't know.
Okay.
I would assume, hi Gregory, I would assume that particularly for the houses, it was made similar to brownstone. And so those were also veneers. And so, you know, for all of the townhouses in Brooklyn, unless it was brick, all of the stone was a veneer stone. So I would make that assumption. And for the bridge, I honestly don't know. The units are so large, in theory, they could be self-supporting. Particularly the ones, if you notice, from the top of the building that were pulled down. I think what happens is when you got point loading of the thinner units on the building is when you got all of the structural cracks.
Right. Thank you, Mary. Charles, Flickenshire also wondered about the use of the building, but now we know it's waiting for its new owner. This is another question addressing the Portland cement. This is from Julia Manglitz. Since Portland was used in repairs in Portland cement of today, it's much different than that of the 1870s. Was the mix adjusted to mitigate the difference in material strength?
It was mitigated, yes. Do I know how it's going to, the efficacy of it? Absolutely not. It does concern me. But again, you know, there was no time on this project, which it was really unfortunate. And again, this goes back to, I think, a real lack of technical information available to the public about how to repair these materials. And that's the reason the Getty put the book out, which showcases case studies in both the US and Europe, is because this lack of information. And I cannot fault, you know, the people that were in charge of this project because it just wasn't available. There was, and, you know, I know there's been some disagreements and there's some people that are quite angry about it, but I think, you know, it's not easy to find this information unless you're in the field, and that is a detriment to a lot of buildings.
Right.
Karen, can I just, a question comes to mind. When you spoke about treating the surface of the building in terms of, you know, things pollutant, well, you didn't use the word pollutants, but things coming back or the buildings darkening, what are the techniques? Because we all see a building who's been beautifully cleaned, and I remember Trinity Church when it was first cleaned down in Lower Manhattan, and it was just a beautiful rose color, and I just felt so quickly it started to, you know, darken again. Are there techniques that help delay that?
Not really. I mean, there's a number of reasons, I think, for some of this, and today with climate change, biological growth is being found on buildings and building materials much more quickly than you would ever have had it before. You also have to be careful with cleaning, that when you clean it, you destroy the biological growth, but if you can't remove it fully, it becomes food for the next generation.
Thank you.
Mary Dietrich, she again congratulates you on a wonderful lecture and a wonderful story, and comments that she will look at Brooklyn brownstones with a more discerning eye. This is from Jack Prince. Did you ever consider blasting the surface to clean up the exterior?
No.
Okay.
Well, I mean, yeah, no, we didn't. There was already a significant loss of detail to some of the ornament. And we were really careful as we were trying to remove sort of the cementitious mixture of paint off of this. It was a real concern. We didn't want to lose any more detail than we already had. And the ornament actually seemed to weather, well, it did weather much more than the actual blocks themselves. My guess is because of the molds it wasn't as easy to ram when you were doing the ornament as it was when you had a rectangular block.
Right. Thank you. we probably had like 10 minutes of questions, but there was like a shorter lecture, Mary, if you would be willing, and we still have quite a few questions. Would that be okay? If
Yeah, no, it's fine.
keep on asking you a few more. Richard Perlman, how many and how and much is the old techniques used today in modern buildings?
If you mean the Coignet Building with the dry tamp, not this type. I think it's probably too expensive. You can find dry tamp cast stone from the 1930s. We worked on a building on Staten Island that will remain nameless, which had some of the worst dry tamp cast stone I've ever seen in my life. And it was just a hazard, and it was sort of a semi-public building that should have been netted and shut down. I was worried about that, but you won't find. Coignet Building was made in that period, I think, up until the company went bankrupt. And there was a whole scandal behind that. I think that somebody ran off with some of the funds or something.
Right. This is from John Belvica. Can you speak about cement that the Romans developed and compare it to today's concrete and cement?
Actually, that I can't. Yes, I cannot, because
Okay.
I'm not totally 100% sure on that, so I'm not going to go there.
Okay. Stuart Anthony wonders, do you use weathering machines to test your samples?
We have used weathering machines. In this case, we could not. There was not the time for it.
Right. Again. Okay. That's right.
But one of the things, though, is if you have cementitious patches that you're trying to do, you can put them up on your roof, and you can put them out on a balcony, or you could put them outside and just leave them for 6 months. And that gives you a much better sense of what the color change is going to be over time. I mean, if you could do it for a year, that would be even way better.
Right. Dawn Ladd wonders, how does all the cement in cement trucks compare?
It's completely different. It's a poured cement. It would be closer to what the foundations and the spandrels in the building frame actually were. It's got nothing to do with, this beton aggloméré it's such a stiff paste. And it had to be really done in a factory. It was really rammed. It was put under pressure. The best way maybe to think about that for people who have ever worked with pressed brick, that's another form of material that's done under pressure, and it's actually made a drier brick. But nobody ever makes pressed brick anymore because it's way too expensive.
Okay. This is from Naomi Hasbrook, and she wonders, and you may have mentioned this, Mary. Was the American company associated with Francois Coignet? Was the reinforced concrete pioneer in France in the 1850s to 70s? I'm not quite sure. Let's say, okay, was the American company associated with Francois Coignet, the reinforced concrete pioneer in France in the 1850s to 1870s?
I don't know about the reinforced. The frame of the building is probably reinforced. We only dealt with sort of which was not a problem. We dealt with the veneer of it, and the brick infill, which were the two pieces that we dealt with. We did not have anything to do with the frame of the building, so which was holding up quite well. And so that wasn't the issue here.
Okay.
But I don't know. I can honestly say I don't know. The company may have, because they did use it in their building.
Yes, and I guess she was just trying to be, you know, the coincidence about the also the two names being so close. She was also pondering that. Well, that will be. We just have a couple of more comments from the audience. And Paula says it's amazing this building was even restored given all the issues, and that seems to be completely true. And Julia Manglett's comments, great presentation and such a difficult project. Thank you, Mary.
Well, thank you.
Yeah, so really, thank you so much. You are, I mean, an absolute mine of information, Mary, really, and thank you so much for taking the time to share your expertise and, you know, detailing the project so eloquently. And as you saw from the questions, there was certainly a lot of interest in the different procedures. So we are so grateful that you took the time and trouble to be part of our lecture series. And as I've mentioned before, our final lecture for the season. Victoria, would you like to add something?
Just that we look forward to another presentation, Mary, where you are in our wonderful space. So this, we invite you to, again, lecture on one of your wonderful projects, and the Brooklyn Bridge sounds wonderful, and just thank you for all of your, I'm speaking to you as a native New Yorker too, thank you for all you do to keep all of these wonderful buildings alive and thriving. Thank you.
Thank you.
Yeah, we are exactly what an important role that you and your company play in the conservation of buildings in New York City. And you know, I looked at your website and you have some like incredible projects associated with the company. I'm just going to add that it's likely the first lecture in the fall series, and this ties in with you, Mary. It's going to be Tuesday, October 6th, and it's Building the Brooklyn Bridge from 1869 to 1883, and this is a book by Jeffrey Richman. So we'll hope you'll be able to, you in particular, Mary, will be able to join us, but also that all our audience. And I want to thank Mary. I want to thank Connie again for assistance. Thank you again, Angelo. And we want to thank you, the audience, and we hope you have a great remaining summer, and we look forward to seeing you in the early autumn. Victoria, anything else you want to add?
Just to say to our audience, we're ever so grateful, and we look forward to seeing you at 20 West 44th Street sooner rather than later. We are here, so you can even stop by. Thank you.
So thank you again so much, Mary. You know, what a wonderful lecture that was to end on.
Thank you.
So we're so grateful. I'm going to say good night to you and to our audience. Good night.
Good night.
Thank you very much.
Yeah.
Thanks.